Hello, guys. Welcome to another class brought to you by Distinct Academy. So today we are going to continue with functions, and we are going to do part two of the previous question that we did on functions, but we only did part one because we had divided into two parts. So if you recall this, so this was the question. So these were the first questions that we did. So these were the functions that we were looking at. It was a straight line and a parabola. So today we are just going to continue from question 7.4, and then we'll just take it from there and finish up all the other questions. And go to this side, right? All right. So 7.4 says, hence, what can you deduce about the function f between x equal to -5 and x equal to -3? So let's just look at the function of f. If we look at the function of f, um, so notice that so these were the values of -5 and wait, where's minus? It's -5 and -3. All right, I remember this. So so between -5 and -3, those were the values that we used here. -5 and -3 are these values that we used to find the gradient. So our gradient was -5. So already from the gradient, we can tell what the function is doing between those x values. So it means that I'll write this. So 7.4. So to answer this question, we'll just type, we'll not type, right? The function, the function, the function f is decreasing. The function f is decreasing because function x is decreasing because the gradient is negative, and then comma, it is decreasing because the gradient is negative at an average average rate of 5. In this case, I'll just say y units because we are not given the units, but we know that um, yeah, we can just say that y units. So that's the answer. So that's the state of the function between those values that are given here, between the values of uh, -5 and -3. So it was a follow-up basically from the previous question 7.3. So let's move on to the next question. So 7.5, determine the values of x for which f of x is greater than 0. So if we go back to look at the function of x, so this is the function of x. So if you look, so this value here, we found this value, and this value was -3 here, and this value here is 0. So between those two x-intercepts, right? If you look at, so let me just go back this side and get some space. So another way of doing this, one way of doing this is to say 7.5 is to say when they are talking about f of x being greater than 0, you want to know where is the function greater than 0, right? If you look at that function that we were given, that function here, it looks like something like this. You have a parabola like this, and then here you have a 0, and then here you have a -3. And if you look at this parabola, you'll notice that this part here of it is above 0, because all the y values here are above 0. And what is that? That is when x is less than -3. And then if you come here also, you look at this portion here, you'll notice that this part here, when x is greater than 0, the function is also above 0. That is, all the y values that you get from here on the function would be greater than 0. So what can we conclude from this? We can conclude that um, the x values for that satisfy this condition are x less than -3 and x greater than 0. So you can write it in this form of an inequality. So that's it. So we move on to the next question. 7.6. Give the coordinates of the turning point of f of x minus 2. So let's do this one. So we need the function of f of x. Let me see if I still have the function of f of x. So the function of f of x was given by let me do this. Let's do this. The function of f of x 7.6. So the function of f of x, right? I'm just writing this for us to remember. F of x was given by x into x plus 3. But now we have f of x minus 2. So if we transform this from the given f of x, we'll have x minus 2, and then we'll have x minus 2 plus 3. So this is equal to x minus 2 and x plus 1. So now they want us to find the coordinates of this function. So to find the coordinates of this function, we can continue to write our f function in the form of, remember what I introduced last time, in this form. We can write it in this form: a into x minus p squared plus q. And if we are to get it in this form, then we will continue here. We will continue here and have what are we going to have? We're going to have the function minus 2 equal to, let's just expand the brackets. If we expand the brackets, we'll have x squared, and then we'll have minus x, and then we'll have minus 2. So now if we complete the square, we'll have x minus 1 over 2, and then all this squared, and then minus 1 over 2 all squared, and then minus the 2. So this will be x minus 1 over 2 squared minus 9 over 4 if you work this out. So from this we can tell that our turning point will be it will be the opposite of this value, which is going to give us 1 over 2 and minus 9 over 4. If you remember last time, the coordinates that we had were, the turning point that we had was, we can go look at it. The turning point was given by, you can see it was given by minus 3 over 2 and minus 9 over 4. So this still makes sense because you'll notice that our y coordinate for the turning point is still the same, but what changed is the x. So what changed is the x. If you check, the x has now moved to, it has moved to, let's just check it. You'll notice before our x was minus 3, so now it has moved to the right. It has moved to the right, 2 units to the right, basically, from this transformation. So from minus 3 over 2, we have now moved 2 units to the right, and we found ourselves at minus 1 over 2. So you can verify that. So we can move on to the next question, which is 7.7. So question 7.7 says L is a point on the straight line and M is a point on the parabola such that LM is perpendicular to the x-axis. Show that the expression for LM can be written as LM is equal to that what is given there. So if we look at LM just from the function, from our original function, so this is LM. So LM is this distance that is perpendicular to the x-axis. So they want us to find this distance here. They want us to find this distance here. So to find that distance, we are going to do the following. If I then start, let me use a different color now and just use black. So for 7.7, what we'll have is, so LM is the vertical distance, right? So to find the vertical distance, we'll just say LM is equal to, if you looked at those functions, you will notice that the the function of f, actually, not the function of f, it's the function of g. If we look at it, I think from that point where we have LM, yes, the function, yes, at this point here, at this point, the function of g is above the function of f. So to find LM, therefore, to find LM, we can say that g of x minus f of x, right? This gives us LM. So now, what is the function of g, g of x? G of x was given by minus 1 over 2 x plus 2. And f of x was given by x into x plus 3. So if we work this out, we will have, what will we have? What will we have? What will we have? What will we have? We will have minus x squared minus 3x minus 1 over 2x. And then we'll have minus 2. Am I correct? Wait, this is minus x squared, this is minus 3x, this is minus x, then this should be a positive then. This should be a positive. So this is going to be equal to minus x squared. What does this give us? these two are going to give us minus 7 over 2x, and then we have the plus 2. So we can just factor out the minus sign and just put it outside. Then we'll have x squared um plus 7 over 2x minus 2. So this will be we keep this minus, and then we'll have x plus 7 over 7 over 4. We are already doing the complete square. This all squared minus 7 over 4 all squared minus 2, right? And then this will reduce to x plus 7 over 4 all squared minus 81 over 16. But if we multiply this by the minus sign, then we will have minus x plus 7 over 4 all squared plus 81 over 16. So we have now proven that LM is equal to this. So this is what we were required to prove according to the question. The question said we must prove this. So if you check it here, you can confirm that the answer is correct. So with the last question now, they're saying, hence state the maximum length of LM and the corresponding X value at which it occurs. So to find the maximum length of LM, we want the maximum length of LM, and the corresponding X value at which that maximum occurs. So how to find that maximum is using what we got for our LM, right? Using what we got from here, when you say 7.8 would be, so what we can do here is we can just expand, for simplicity, we can just expand this function and say this will be, if we keep the minus, we'll have x squared plus 7 over 2x, and then plus it's gonna be plus what? It's gonna be plus 7 over 4 squared, and then outside the bracket we have plus 81 over 16. So this is still our LM, right? This is still our LM. So if we um take this out of the brackets, we have x squared. Let me just put LM. We have minus x squared, we have plus 7 over 2x, and then we have I'm just gonna keep this. No, it's fine. Let me just type it in the calculator. Um, it's 7 over 4. 7 over 4 squared. That gives us 49 over 16, but it's a negative because we have a minus here and we have a minus here. We have a minus here. So it's a 49 over 16 plus 81 over 16. So we don't need to even continue with these for these purposes, but for the exam you can work this out. This is just the constant. So if we find LM, if we find the derivative of LM, this will give us minus 2x, and then this one here will give us minus 7 over 2. So if they want the maximum, it means that the maximum we get it when the derivative is equal to 0. So the x values will therefore be what? It will be minus 2x minus 7 over 2 equal to 0. Then this will give us x is equal to minus 7 over 4. This is the x value at which the maximum will occur. So so that maximum will be what? That maximum will be when x is equal to minus 7 over 4. And we can already see there, if you substitute the value of x here, this whole thing in the bracket will be 0, and then you'll be remaining with this. So the maximum value of Lm, therefore, Lm max is equal to 81 over 16. Thank you, guys. We have come to the end of the session. So if you do have any questions, you can mention them on the comments. Thank you. Bye.